Thanks everyone for coming. Sorry I couldn't be there. COVID hit the family this past week.
Can you start that again? Because I
Yep.
hadn't unmuted the room.
I was just saying thanks for everyone for coming. Sorry I couldn't be there. COVID hit the family this past week, but we're doing all right. Just not traveling anywhere yet. Let's see. Noah asked me to mention also, for those of you going to dinner, which I don't know why he's asking me to announce this since I can't go to dinner with you guys. But the dinner, the bus is going to leave right at 6, and then the dinner starts at 6:30, which is a little earlier than we had said before. So just a reminder to keep your eye on the watch.
I should have not asked the person who's not doing dinner to do. Sorry. The bus is leaving. We're leaving here at 6. The bus leaves sharply at 6:15. But dinner, and it's about 15 or 20 minutes away, so dinner will start at 6:30. So close, Aaron. Sorry, I didn't really give you enough information.
That's fine. I don't need this information. All right. So you know, I went to write the abstract for the book and put together these slides. I came up with a few different sort of interesting stories that I thought I'd put together. They don't necessarily connect, but hopefully you find them interesting. And I thought I'd start with my start in Code Lab. I went back and I pulled a quote from my graduate school application essay where I said, I believe that multi-robot systems and computer vision are the most important fields in robotics. And so, as you'll see, if you don't already know my work, that's not at all what I worked on. It's not at all what Dan usually works on. So, you know, it's often, I think people have said, you know, Dan has this nose for talent or something, but he was also sort of smart enough to ignore what I wrote and just say, no, you don't want to do that. This. I think you want to be in this lab, and so that was you know, very insightful. Yeah, and I guess I need to get better at ignoring the students' wishes, or I'm not sure what the lesson there is, but it worked out pretty well. The other recommendation I had from my undergrad advisor, Howie, because I spent my whole undergrad building up new snake robots, and Howie said, Aaron, you know, you just did a huge infrastructure project. Go to a lab where you don't have to spend your whole time building stuff. And I was like, okay, no problem. Code Lab. They've got Rex, they've got Rise, they've had them for years. Like, there's going to be plenty of robots. And I show up at Penn, and there's not a single working robot in the lab. And we a couple were close, like the Edubot in this picture here, I think was almost working, but when I arrived. And then, of course, I spent a lot of my time working on XREX and the whole XREX ecosystem with Clark and everyone else. So I guess I ignored that advice as well, but it worked out. And then the other thing I thought was sort of really interesting was anytime you had your first meeting with Dan, I think we all, most of us at least, remember that very vividly, of talking about these sort of amazingly grand ideas. I remember coming out, I had first a phone call, and then a meeting in person on the visit day, and coming out and like writing out a list of like 10 things I had to go look up, starting with what was a manifold, was the first thing I had to look up after meeting with Dan. And it was sort of, you know, a life-changing experience. And then in later years, when we had the PhD visit weekend, you know, each year a new crop of potential students would come. The PhD students, I think this was probably mostly me and Denise and Goran, but some subset of us would always try and schedule ourselves to get the meeting right after they met with Dan, because they kind of always came out a little shell-shocked, and they needed some time to like process what had just happened. And we always tried to catch them at that moment. As for the research, one of the things that I think is amazing about Dan's lab and this community is this mix of theoretical and empirical results. You know, clearly Dan is the driving force on the theoretical side. I don't want to say anything insulting on his you know, practical skills, but I think once you get to know Dan and you work with Dan for a while, if you look back, it's kind of surprising that there's such good systems and so much good empirical work that comes out of the lab. And I think this is, again, getting back to that nose for talent, and maybe he's just good at recruiting people that complement his skills, I'll say. But it's sort of, I think, pretty rare to have such strong, you know, theoretical advances and empirical advances coming out of the same lab. And so I have an example here. This is from one paper from my thesis, the ICRA 2013 paper on leaping, that introduced this topological ground reaction complex that accounted for the sort of dimension adjacency properties of different contact conditions, and also introduced all of these jumping behaviors, jumping up onto ledges and across gaps and stuff that sort of improved the, at the time it was the sort of the highest ledge or the farthest gap. I forget exactly what the records we claimed we had there were, but real sort of advances on both the sort of theory and empirical side in one conference paper. And I think that's sort of very emblematic of the lab. As an update to this, so this, on the right was the sort of the splashy video that we made for Penn. All of these are, I'm sitting at a laptop, I hit enter and it jumps, and that's it. There's sort of there's no perception, there's no planning. I line the robot up and then I hit enter. So since then, in my lab, we've been doing a lot of work on legged controls and thinking about the whole stack. So yes, the sort of control to jump and the sort of specific behaviors, but also the higher levels, which we call sort of the global planner, that will get around obstacles and then decide when it needs to jump and get over obstacles. So these are all of these results are part of a few different papers, and then also part of what we're calling Kod SDK. So we're releasing this sort of whole control stack, open source. I guess officially we'll release it at the legged robot workshop on Friday, but I'll give you guys a preview here that this is coming out. And so now taking, in my thesis, the thesis work could maybe get just the very middle part of that video. Now it can actually be sort of part of a functioning, useful system. The other parts of my thesis were also sort of similarly, jarring in terms of the mix of theoretical and empirical results on the self-manipulation framework, using sort of manipulation tools to explain good stuff, consistent hybrid systems on the theoretical side. But then, the first project I did in the lab was this very empirical contact detection using proprioception on edubot legs to solve this maze, and of course all of the tail work to try and do different reorientation behaviors in the air. So I tried to take this sort of mix of theoretical and empirical into my own lab. I think probably the balance in my lab is a little more on the empirical than the theoretical so far, but we've got a good amount of both. And so a couple things I'll highlight here was on the left is this idea of how to map distributions through hybrid systems. And a lot of this is inspired by Sam Burden and others in the room. And taking this idea of a saltation matrix, which maps variations, and now applying it to distributions like probability distributions for common filtering, or value functions for ILQR, and also some stability analysis. And then on the empirical side, we have this large project in my lab on environmental monitoring. We're sending robots out to look for contaminants in soils, which we're using a lot of legged robots, yes, but also wheels and tracks and other sort of morphologies. So the next sort of vignette or quote, I guess, is that I'd like to bring up would be that Dan used to say that students needed to wander in the desert, meaning that when a PhD student starts, they should explore, they should think about different ideas, they don't need to settle on a thesis right away. But it was very confusing because a lot of us actually went to the desert to go wander around. And so I think I went on a total of 4 trips, 3 to the Mojave Desert with Clark and others, and then 1 to the Jornada and White Sands deserts with Sonia and Jeff. And in truth, both senses of the term were very important to me, to my development. I think I definitely benefited. I definitely didn't know what my thesis was going to be at the beginning or even a couple of years in necessarily. And I also got an incredible amount of insight and inspiration from these different field trips out to the desert. And the videos from these trips, would be in every presentation I would give for at least 10 years since then. So a couple things I wanted to say from the desert experiments here. This is one of the first pictures Clark and I took. On the first trip, we took an original research Rex, which we gave some robustness upgrades because the original one was pretty flimsy, but toughened it up a little bit and got it working. It wasn't working when I got there, but Clark and I figured out how to get it working. Took it out to the desert in 2009. Worked on sand, worked on rocks. Here's an action shot of Clark driving around with his cool desert getup. Here's an action shot of me looking cool with the robot on my back. But we spent a lot of the trip doing this, fixing the robot. So here's a picture from 2009. Here's a picture of me and Denise from 2010. I swear these are different trips. They look, it's the same outfits, the same robot. So this is what really, the robot at that point was about not quite 10 years. I mean, the original Rex it's been about 10 years. I think this version was maybe 8 years old. But it was time for something new. And so that's what motivated us to build X-Rex and XRL and all the derivatives that came after that. And Dan would always ask, are we just building YAR? And he would say it like, like a good pirate, like YAR, yet another Rex robot. But it really, I think the X-Rex project and the XRL and everything, I mean, it took a lot of time, my time and everyone in the lab. But it really opened up a whole second decade of relevance for Rex. We really did need to do this to get it to work reliably in the desert, to handle all the payloads we wanted to put on there. X-Rex was the first legged robot with a GPU on it, and we did all sorts of sensor-based stuff that this sort of enabled. All right, so students should wander through the desert. Advisors should also wander through the desert. So here's Dan from the second 2010 trip in a real, I would say, Gandalf the Grey kind of moment on that trip. And and this is something I've also tried to bring into my lab. So far, I've only managed to send one student to a desert, but I did send a student to the Atacama Desert in Chile, working on a project she's funded through NASA. Doing the main project is this thing on top where this Mars rover type vehicle is digging trenches in the sand. And so Catherine's built up a terra mechanics model of how to model the forces, as well as to model where the sand goes, if you want to use your wheels as if they're end effectors for digging. And on this trip, she snuck along and brought a mini Rex. So mini Rex is this little $200 sort of platform we made for outreach. And it's small, and so she shoved it in her carry-on bag or something, and brought a mini Rex out to the Atacama Desert. Although it was a little small for the size of obstacles that were out there. So the next thing I wanted to bring up was the sort of legacy of Rex, and I think these videos will play. Here I have this video. It's called Rex First Steps. I wasn't, around in the lab at that time, but I take this file name at its word that these are some of the first steps of Rex. I believe this video is circa 1999. Probably there's people on the phone call that can correct me if this is not actually the first steps or the wrong year. And then here's a montage we made of X-Rex circa 2009 or 2010. And what is the legacy of Rex? I was talking to Clark this morning. I'd be curious to hear from the audience if anyone is still using any of the X-Rexes that we built in the second decade of its relevance. But let's call it sort of 20 years. Maybe it'll continue on for a third decade of relevance in research. Why is that? I think some of it is the simplicity helps the longevity. So if you can show something on a simple robot like Rex, I think that carries more weight than if it's on a more complicated robot. And it's also, I think, it's something where we really deeply understand the dynamics and the control. And any paper we write about Rex has all of the context from the many, many, many papers I'm guessing 50 papers. I did not go through and try and count them, but at least 50 papers that have been written about Rex over the years. So I'd like to call Rex a model organism, to take a term from biology. I'm not a biologist, so maybe I'm misusing the term. But I think of it as sort of a model organism for robotics. Things like the PR2 and the quad rotor would certainly be in that category where there's value in doing research on them because there's all this context and we understand them and all of these other things. I tried to recreate, I thought I had an original copy of it. Dan used to give talks and present this slide with 16 different videos of Rex going simultaneously. I apologize, I don't know which one's making noise. Mute it. Hopefully the sound's not coming through. One of these is very loud. Anyway, I always thought that was pretty funny. Dan had this slide that had 16 videos of it. Maybe someone has an original copy of the slide that Dan used to use going off Rex, but I always enjoyed it. In a similar vein, as we all know, Dan used to be an English major, and he once told me that the thing that he liked about English was that it has infinite depth. You can always add an extra comma, parenthesis, hyphen, etc. And as anyone that's written a paper with Dan knows, this leads to trouble. So Dan's prose is always formally correct. If you read it, it'll parse out, no problems. But they can be quite long sentences. And so I would find when I was writing papers with him, he would send me some text and I would just go through it and I'd be like, period, capital letter, period, capital letter, period, capital letter. So I did some time digging around. I was able to find this set of 2 sentences that made it into a paper, made it into that ICRA 2013 paper. I think between these 2 sentences, there's something like 5 commas, 4 parentheses, and a hyphenated phrase in just 2 sentences. So I would say that's pretty characteristic Dan prose. I'll let you read this on your own for the sake of time. I have no clue how much time I have left, but because we started late. Before I wrap up, I just wanted to quickly introduce, so I'm not there, but I have several students there. And so I wanted to just quickly introduce who they are. The first is Justin Yim. Justin actually is technically a Code Lab alumni because he spent about a day or 2 in the lab as an undergrad at Penn. And then I think we gave him something really boring, like soldering a motor controller or something. And then he said, this is boring, I'm gonna go work for this other lab, Mark Yim's lab. And as luck would have it, I was able to get him back as a postdoc. So he's a postdoc in my lab now. He'll soon be a faculty somewhere. I don't think he's made a decision, but you should ask him if you're there in person. And he's presenting at ICRA this simple bipedal robot. So this is a single actuator per leg walking robot, which of course is one of the taglines of Rex. This one though is a bipedal robot that can still start, stop, turn, everything with just 1 actuator per leg. And he's also working on locomotion in underbrush. James is a PhD student who's presenting a paper at ICRA that we call hybrid event shaping. And this is relevance. We talked this morning, there were some presentations on the paddle juggling. One of the applications of this work is trying to understand the stability properties of things like paddle juggling. So the idea here is to shape not just the like time and velocity that you hit a ball or have some other hybrid event, but also the shape around there. And again, using these things called saltation matrices to improve the stability of the periodic system. So that's pretty cool. It also helps explain things like the Raber heuristic and swing leg retraction in bipedal walking, and we can then apply it to any hybrid system. And then James also has a poster at the workshop on lethal autonomous weapon systems on Friday. Jan House is a master's student that's here, and he's presenting a poster at the Legged robot workshop on proprioception and tail control, especially for robots sort of falling off of cliffs and these kinds of things. Shane is a master's student working on the environmental monitoring project. And then Ardalan is a PhD student and Jiming is a master's student. I think at least Ardalan is showing up later. I don't know if Jiming is there yet. But Ardalan, Jiming, Yan Hao, and Justin are all part of the team that built Quad SDK. So that sort of open source, full stack, legged control software. A lot of the lab is worked on, including those guys that are there. And again, that'll be presented at the legged robot workshop on Friday. So I'm not there, but please ask my students about all these different projects. So in conclusion, thank you, Dan, for teaching me how to think and also for helping me to launch my career. And I thought I would end by summarizing my ongoing work in a way that Dan will understand. So here's everything I'm working on.